Hey guys, welcome back to another episode on trigonometry. Today we'll be looking at Pythagoras' theorem. Yes, the all-fed popular PT. All right, guys. So last session, if you looked at my video, you would have seen where you learned that the basics of trigonometry is where we usually deal with a right angled triangle. So I'm going to draw a lovely triangle on the screen there. And to represent our right angle, I'm going to put a 90-degree in there. Now, we also learned last video how to name the sides of your triangle properly. So the first thing you can do is identify where your right angle is located, and that side that's directly opposite is called the hypotenuse. And then also I need to have some sort of a reference angle theta. So in this case, I'll choose to put one down there. And because our angle theta is located on the bottom there, then that means the side opposite that angle theta will be called the opposite, or OPP for short. And of course, by default, your third side will have to be the adjacent. So there you have it. You have the three sides properly named of a right angle triangle. Now, a point to note is that in a right angle triangle, the hypotenuse tends to be the longest side. So I'll just write that in there as a bit of extra info. And let me just write this properly. Okay, that's the longest side. All right, and Pythagoras' theorem is just simply a formula which relates these three sides. And a very frequent formula that you will see is c squared is equal to a squared plus b squared. And I think that sometimes it's this formula that tends to, I don't know, but it tends to cause much distraction and despair to students because they mix up the values of A, B, and C. So here's how I like to teach this theorem. Now, since the longest side of our triangle is the hypotenuse, I like to teach it by saying Pythagoras' theorem shows the relationship between the hypotenuse, opposite, and adjacent such that the hypotenuse, which is our longest side, squared, is equal to the sum of the other two sides, each squared. Now, do not make the mistake and find the sum of the two sides and then square it. These are not equivalent to each other. Okay, so there you have it. That's pretty much Pythagoras' theorem. You have the longest side is simply equal to the sum of the other two sides individually squared. Okay, so how does that help you in life? Well, we'll have to look at an example to see. So let's get at it, okay? Let me draw a triangle on screen here. And I'll make this a very popular one, I shall say. Let's just say the side of this, first of all, we need to make sure we identify our sides. So because this right angle triangle is similar to this one over here, I would not put in the labels, the sides, for the reason that it's already on screen. Okay, so let's just go ahead and give our side some actual numerical values. So let's just say, I don't know, let's call the opposite, let's give it a value of 8 meters high. Of course, this is not drawn to scale. And let's give that adjacent a value of, let's just say 6 meters. So you have the measurements of two sides of your triangle. What if they asked you to find the length of the third side? And the question goes like this. Find x. Well, what can you do? Well, this is where Pythagoras Theorem comes into play. Pythagoras Theorem is usually used to find the missing length of one side of a right-angled triangle. But there's a condition, and the condition is that two out of those three sides of that triangle must be known. Once those conditions are met, then you can go ahead and you can simply apply Pythagoras' theorem. So let's go ahead and apply. Well, in this question, we can see that the hypotenuse is the side which is represented by the unknown x. So we will replace that hypotenuse with our value of x. So we have x here. What about the opposite? Well, in our first diagram, the opposite is that side there. So therefore, 8 represents the length of our opposite. So we write that value into our formula. And then by default, obviously, the adjacent will simply be 6. Okay, so it seems like all we need to do is simply plug that into our calculator, and you should get x squared gives you the sum of that 64 plus 36, and that's 100. So just erasing this here, you will get that, let me just draw a line here. You will get that x squared is equal to 100. Therefore, x is simply the square root of 100. Remember, when you're trying to get rid of a squared function on one side of your equation, you simply find the square root on the other side. Okay, so that's a very nice way to think about it. And the square root of 100 is simply 10. And because we're dealing with actual lengths here and the question has given us dimensions, we need to remember to put in our dimensions. So the final answer for this question will simply be that the length of the hypotenuse, x, is equal to 10 meters. Now, we have different types of questions involving Pythagoras, where not every time they'll ask you to find the hypotenuse. Sometimes they can ask you to find the opposite. Sometimes they can ask you to find the adjacent. So let's get into some trickier questions. So just keep it rolling. Okay. So let's just say, I don't know, let's change it up a bit. Okay. So we have our right angle triangle there. I'm still going easy on you guys. It's your first time, okay? And let's just say we still have theta there. And let's label our sides first of all. So opposite our right angle is our hypotenuse, HYP. Then opposite our angle of theta, we have opposite. So that's OPP. OPP in the house, y'all. And then we have ADJ. That's cool. So we have everything. Now I'm going to give 2 out of my 3 sides a length. So last time we actually had the hypotenuse as the value of x. So this time I think I'm going to make my adjacent x. Well, actually, let's change the variable. Let's call our variable y. Let's change things up a bit. Let's increase your level of understanding. Let's increase your thinking capacity here. So let's just say that in this question, our hypotenuse were 13 meters. And our opposite, let's just give it a length of 12 meters. And they want to know what's the value or the length of your adjacent. and they have identified it by the letter Y. So once again, when you're dealing with Pythagoras' theorem, you always pull it out when you have 2 out of the 3 sides of a right angle triangle, which is the case we have here. So remembering the formula goes like this. That longest side, which is the hypotenuse squared, is equal to sum of the other 2 sides individually squared. All right. And a point to note is that for this formula, you can actually write it as the adjacent squared plus the opposite squared, or vice versa, because when you square these values, they're always going to be positive. So in this case, the order in which you write or choose to remember your formula or your theorem is not essentially important. Only for this theorem, okay, because addition generally is not commutative. Okay, so let's go ahead here. Now we have values for the hypotenuse. So let's start substituting values here. The hypotenuse is given by 13. So we will write that in 13 squared. What about the opposite? We have the opposite being 12 squared. And then the adjacent has been represented by that value of y. So we'll write y squared. Now this does not look as easy as the one previously. So all we have to do here is just a bit of algebra. We just need to make y the subject of the formula. And how do we do that? You can check my video where I did an entire session on making a certain variable the subject of the formula if you are having issues with that. But in this question, we'll get straight into it. So we want to isolate our variable y. One thing you can do when you recognize that your unknown is located on your right-hand side is you can do a flip. You can perform a flip where you simply flip the right-hand and the left-hand side. And this is a safe move to do if you're not too strong on your algebra skills, because it causes no change in signs if you completely flip your left-hand and right-hand side. Notice there are no changes in signs here. And we have gotten one step closer to our answer. We have that unknown variable y on our left-hand side. And to isolate it, we still need to get rid of that 12 squared. So we want that 12 squared to go across on the opposite side of our equal sign. So to do that, we'll simply subtract 12 squared. And we're almost there. Now, there's 2 ways you can do this question. You can go ahead and in the next line, you can isolate your variable y by getting rid of that squared sign. You can find the square root of the right-hand side, or you can go ahead, you can go to your calculator, you can work out 13 squared subtract 12 squared. You can get a value first, and then when you have finished that calculation, you can go ahead and then isolate your variable and find your square root of 25. Okay, so from here, there could have been 2 different steps. Some students may have done it immediately. Some may have chosen to take a step or 2 further. All right. So that's your answer. You need to check your question. Did they give any particular units? Yes, they did. Their dimensions are in meters. Their units, sorry, are in meters. So you want to make sure that you state that your question had units. So your answer for y, which is the adjacent, you can state that you know that the adjacent, which is the side you were trying to calculate the length of, was found to be 5 meters. Okay, so I'll be doing one more question where I'm going to just do a bit of a change around of this diagram. Okay, so we're not going to get a standard looking diagram this time. Okay, so here goes. All right. So let's draw a twisted triangle. A twisted triangle. So, oops. I'm sorry. So, our twisted triangle might mean that some of you guys have to turn your heads. You know, you have to look upside down to see it. But the reality is, if you really truly understand how to label correctly the sides of your right angle, this will not be difficult at all. So just trying to get a lovely, nice little neat triangle there. Boom, there we have it. All right, so I'm going to draw my angle theta here. So it looks confusing, right? This is the cream of the crop where students just drop everything and they're like, okay, I give up, that's it. Yeah, I just do not know what to do. Hey guys, relax, take a breath, look at your diagram again, and remember your basic rules. Wherever your right angle is found, that line, that side that's directly opposite it will always be your hypotenuse. Nothing changes that. Wherever you have your theta or your angle present, the side that's directly opposite that is called your opposite. That also does not change. And the last side by default must be your adjacent. Was that so bad? It wasn't that bad, was it? You must admit. Okay, so now that some of you guys hopefully are relieved, let's get on to giving this triangle some values, shall we? So let's make the opposite our unknown in this question. Let's call it z. I like to write my z with a cross in the middle because it looks like a 2 without it. So for differentiation purposes, I really do prefer to write any letter that looks like a z with a cross like that. Okay, so let's also give this triangle some dimensions. Let's just say the hypotenuse has a value of, I don't know, 13. Let's just say this is 13 meters. And our adjacent, let's give it a value of 5 meters. Take note, throughout this video, I have used meters, but your units can be centimeters, they can be millimeters, pretty much they can be any dimension because it's just the length, okay? I keep saying dimension, they can be any unit of measure. All right, so guys, the question we have on screen is to find, I think my pen is scared. It keeps erasing itself every time I try to write. Okay, and it's not. We are going to find a z, guys. Z. Whoa! Didn't believe that pens would be scared of trigonometry. Wow. Okay, so let's set up shop here. What's our basic formula? Well, the longest side, which is your hypotenuse squared, is equal to the sum of the other two in any order. I usually always start with the opposite. You can start with the adjacent. All right, so let's start substituting values here, shall we? So we do have that the opposite has a value of 13 here. Yes, 13. So we will plug that in. We have this being 13 squared. Do we have a value for the opposite? Nope, but we have an unknown. So the opposite is our unknown, which is z squared. And finally, our adjacent is that value of 5. Now, please do not write in meters. It's a formula in which you are inputting the constant values of the length. So please do not write 13 meters squared is equal to z squared plus 5 meters squared. Nope, 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 and nope. Okay, so get the hang of remembering to only write your numerical values into your formula. Okay, guys? All right, so we can go ahead and we can begin making or isolating that z squared. Isolating is kind of easy here. Here we can just say z squared is equal to, here's another way you can isolate z. On the left, we will keep our 13 squared where it is. And what we're going to do is we're going to get rid of this plus 5 squared here. We're going to carry it across on the opposite side such that it becomes minus 5 squared. Okay, so some students, you may have written this as, instead of what I have on the screen, some of you may have minus 5 squared plus 13 squared, and that's also correct. It just simply depends on which number you choose to write first. I always like to write whichever is positive as my first term. So 13 is positive, so I wrote it first, and then I carried across my positive 5 squared so that it became negative 5 squared. Okay, so finally, one last step we are going to do is, unlike how I did the last question, I'm going to do the quicker method. Making z the subject in one quick, simple way, we are going to find the square root of 13 squared minus 5 squared. And that's it. See how short? That was just 1, 2, 3 lines and 1, 2, 3, and we're done. That's it. You just plug this into your calculator. Now, point to note is that if you plug, well, in some calculators at least, if you plug 13 squared minus 5 squared into a calculator, some calculators tend to work out a part under the squared sign, and then they don't include the entire thing. So you may need to include your personal brackets in your calculators in order to get the correct answer. You can test your calculator and see if it's a smart one. Okay, so some calculators are programmed differently. So just make sure you check that if you are using your calculator to work out questions like these, okay? And on my calculator, let's see, 13 squared minus 5 squared gives us 144. So therefore, z, the square root of 144, is simply 12. And the units in our question were meters. And that's it. That's your answer. So if you'd like to see more examples on how to apply Pythagoras Theorem towards finding different types, different lengths, different sides of your triangle, especially if the triangle is pretty twisted like this one here, where it's drawn, you know, upside down, it has a weird orientation, be sure to leave a comment down below, and I'll do actually a full tutorial containing several questions like these with twisted triangles. Okay, guys, so glad to be with you. Thank you so much for looking. Be sure to share with a friend, and I'll see you guys soon. Take care and bye.